Hi everyone. In this video, we are going to look at some other types of lines. So I'm going to give you new context. In this context, we are still running a candle business, selling each candle for $10. What you're going to see in the table below is the data representing revenue for her first 10 week of sales. So before we were talking about profit, in this video, we're going to talk about revenue. So we're going to let X represent the week. So if you look at the table, this would be week 1, week 2, week 3, week 4, week 5, all the way up to week 10, first 10 weeks of sales. And in this video, our Y coordinates are going to be revenue instead of profit. Okay, so that's a dollar amount revenue. This is a week number. Okay, so when I say revenue, I'm saying how much money I bring in, not necessarily how much money I keep. So the other graphs were potential profit graphs. This is going to be my actual revenue graph. And what I'm going to do first is plot all these points on the coordinate plane you see here. And I actually want you guys to do this on your own for practice. So go ahead and pause the video, plot all 10 of these points on the graph, and then I'll come back with the answer and you can check. No cheating. Make sure you pause. Okay, if you take a look at my graph, yours should look something like this with your points. Very different looking. So from week 1 to week 2, you make $0 in revenue. So you kind of stay flat there. Then in week 3, you jump up to $10 and you stay at $10 until week 5. After week 5, you jump up to $50 where you stay until week 10. So you kind of get these like 3 different lines here. You could even connect them to kind of see that like jump in revenue. So you start off small, then you stay consistent is the piece here, right? There are a lot of weeks where you have the same amount of revenue and you haven't made any more. And that's why the graph looks the way it does. Okay, so we already plotted the data on the coordinate plane. What I want to talk about is how you find the slope in the equation of a line. So what you're looking at right now is a series of 3 different, if you kind of disconnect them here, you're looking at horizontal lines. Horizontal meaning this way, vertical would be this way. So for this video, we're looking at the horizontal lines. And I want to take a look at any of these and look at the slope. So just because this one's the longest, I'm going to look at this top one here. When we talk about slope, just a reminder, slope is rise over run. So how much do you rise from one point to the other, and then how much do you run? So let's take any 2 points on this line, maybe this point and this point. How much do you have to rise to get from here to here? Rise would mean going up or down. You actually don't rise at all. So the rise for this is 0. And the run between these 2 points, you have to go over 2. 0 divided by 2 is just 0. Okay, if you look at this line, we can do the same thing. You rise 0 and you run 1, so the slope is just 0. Or this one, you rise 0 to get from here to here, but you run 1. So the slope is still 0. So as you can see, all 3 of these pieces of the graph have a slope of 0, and that's because any horizontal line has a slope of 0. All horizontal lines. The reason all horizontal lines have a slope of 0 is because, well, you're not rising to get from one place to the next in a horizontal line ever. No matter what the horizontal line looks like, how big or small it is, or where it's located, you're never rising. You're just running left or right. Okay, so if we want to write the equation for a line, I'm going to choose to use the y equals mx plus b form. Okay, and I'm going to plug in my slope as 0, and my b is my y-intercept. Okay, well, I don't really have a y-intercept on these lines, so maybe choosing y equals mx plus b wasn't the best option. That's when I'd want to go to point slope. So point slope is y minus your y coordinate, let's try that again, equals your slope times x minus your x coordinate. So let's try plugging in a point since we didn't have a y-intercept. Our slope is still 0, and I'm going to pick a point. It could be any point on the graph. I don't know. Let's write the equation for this one since that's one I started with. Okay, a point on that graph would be, let's say, 6, 50. Okay, 6 is the x, and 50 is the y. So y minus 50 is my y-coordinate, and x minus 6. Okay, if I simplify that, y minus 50, I'm just going to leave for a second. And I have 0 times x is 0x. 0 times 6 is 0. So 0 times anything is just 0. Because this would all make it 0 if you distribute it even. 0x is 0 times 6 is 0. It's all 0. If you want to solve for y to get it in slope-intercept form, you have to add 50 to both sides, and you get y equals 50. Okay, since all horizontal lines have a zero slope, all horizontal lines will also look like this. And I like to think of any equation as a rule. The rule of these horizontal lines say all your y values are equal to 50, which makes sense for this line because all of our y values are here at the 50 range on the y-axis. So the y-coordinate here is 50, here is 50, and you can see this reflected in the table. All of these y-coordinates are 50, so the rule just says, I want the line where all the y-coordinates are 50. That's a lot of circles there. So we're going to summarize this and also look at vertical lines, but we're going to start with horizontal lines. So when you have a horizontal line, again, that looks like this, the slope is always 0, and the equation is always y equals whatever the y-coordinate is. It's y equals some number. Okay, I want to give you another example. If you flip to the other side, I could also write the equation for, let's say, this line. It would be y equals whatever the y-coordinate is. So for this one, our y-coordinate was at, as I'm looking at this, I realize I made a mistake that I need to correct. Hopefully you all identified my mistake already. But at 6, which is right, or excuse me, at 3, which is right 1, 2, 3 here, our revenue should have been at 10. So this should have been that line. Correct that on your own if you decided to change it instead of trusting your instinct. So for the equation of this line, it would be y equals whatever the y-coordinate is. And the y-coordinate on all of those points is 3, 10, 4, 10, 5, 10 is 10. And that would be the equation of the line because all horizontal lines are y equals whatever the y-coordinate is. Okay, I want to do the same thing and look at a vertical line. So I just gave you an example here of a vertical line. Okay, and I want to find the slope, and then I'll write the equation. So again, slope is rise over run. Okay, and I want to know how many points I rise, how many points I run. So let's say I pick these 2 points on the line. I'd have to rise 1, 2, 3. Okay, now run is how much I have to go left or right to get to this point. And I would actually need to go left or right 0 because you're just going straight up or straight down. Okay, what's 3 divided by 0? So there's a rule in math that you can't divide anything by 0. You can't take 3 of something and divide it into 0 pieces. It's not possible. It won't work. So anytime you try to divide by 0, the answer is that's undefined. Okay, or another way to say that is there actually is no slope. Okay, sometimes the way I like to think about this is if you were skiing, right? If you ski down a mountain like this, it's a pretty standard mountain. It has a slope. Down a mountain like this would be a little bit steeper. If you tried to ski down a mountain like this, that's you skiing, you would just literally fall to your death. And that's why there's no slope. It's undefined. Okay, if I had a horizontal line and you tried to ski on it, you wouldn't move at all because there's no incline. That's why the slope is 0. So let's write that in our chart down here so you have it. A vertical line looks like this. The slope is either undefined or you can say there's no slope. Okay, either of those is fine. Now for the equation, okay, this gets a little tricky because it's an undefined value. You can't just plug it in. So in the horizontal line conversation, I said I like to look at this as a rule. The rule says all your y values are equal to the same thing. They're equal to a number. Okay, I want to keep that in mind and kind of just plot all these points here, write them out. So this is 3, 0. This would be 3, 1. This would be 3, negative 2. This would be 3, negative 4. What do they all have in common? Okay, they all have in common that the x-coordinate is 3. It doesn't matter what the y-coordinate is. Okay, the y-coordinate is forever changing, but the x-coordinate is always the same. So the rule is the equation. Same thing. Rule means equation. Equation means rule, basically. The rule of this line is that all the x values have to equal 3. And that defines the line. That's how you write the equation. Oops. That's how you write the equation of any vertical line. It's always x equals whatever the number is of the x-coordinate. Okay, so this summarizes horizontal and vertical lines. Okay, horizontal lines If you try to ski on them, you wouldn't move. So it has a zero slope. Vertical lines, you try to ski on it, you'd fall to your death. That's why it's undefined or no slope. The equation of a horizontal line is y equals whatever the number is. And the equation of a vertical line is x equals. This isn't really something you have to memorize. If you just look at the line, again, think about the pattern and you can come up with the equation. All of these have a y coordinate of 3, or excuse me, an x coordinate of 3. That's why it's x equals 3. That's the rule. Okay, whereas if you're looking at this, all of the coordinates had a y coordinate of 10, so the equation is y equals 10. And that's how you would describe horizontal and vertical lines. If you have any questions, please don't hesitate to ask. Have a good rest of your day.